Hi everyone, so this is part 2 of trying to build your own Git with the help of JavaScript. If you have not watched the part 1, you can do so with the help of this link over here. In the last video, I completed 3 out of the 7 stages. In this video, I am going to attempt 2 more stages, 4th and the 5th stage. But before we jump to stage number 4, let's do a quick recap of all of the things that we covered in the last video. If you want to try out the challenge yourself, you can do so with the help of the link in the description box below. Let's begin with a quick disclaimer here. Please don't use this video as a tutorial. This is just me trying to attempt the implementing your own Git challenge provided by codecrafters.io. I've worked with Git before, but this is the first time that I'm exploring the Git internals and how Git works. So please don't expect full in-depth explanation of things here. So this is a recap of stage 1. Stage 1, I created my very first Git command, which was git init. So what the git init command does is that it creates a .git folder. The .git folder is where all of the relevant data is stored that is used by Git to do all of its magic, basically. If you go inside of your .git folder and print out its content, you'll be able to see a tree looking something similar to this. So first of all, it has the head. All right, so this is a mistake here. This is not the description for head. This is the description for index. The index file is also known as the staging area. It keeps track of changes that will be included in the next commit. So whenever you add or remove something from the staging area, that is stored inside of the index file. Head, however, contains a reference or the name of the current branch that we are at. So this head file links to a file inside of the refs here. It basically just contains a path that keeps track of the current commit or the current branch that you're working on. Next, we have config. Config is the configuration file. It stores all of the configuration settings for the repository, such as user info and other repository specific settings. So when you use the git config command, it actually updates this config file. Then you have some hooks. These are scripts that you run before or after whenever you create a commit. Then you have objects. So in this challenge, we are working mainly with the objects. Objects are the fundamental units of storage like commits, trees, and blobs. So these objects are essentially that help you manage your version history. And then you have refs. Refs keep track of branch heads, remote branches, and other refs. These are found in the refs folder. So we'll be talking about Git objects mostly. There are 4 main types of objects. There are more objects than the ones discussed in this challenge, I guess. So Git objects are used to manage and store the history and state of a Git repository. Each type of object has a specific role. So there is a blob, binary large object. Then there's a tree object. Then there's a commit object. And then there's a tag object. All of these objects that we talked about are identifiable by a 40-character SHA-1 hash, also known as the object hash. So every object has an object hash, and these hashes are unique. So this is an example of how a hash may look like. Each Git blob or each Git object is stored as a separate file in the Git objects directory. It's placed in a directory named with the first 2 characters of the object's hash, and the remaining 30 characters are used as the file name. So every Git object has a 40-character hash, which is unique. And these Git objects are stored inside of the Git objects directory. And inside of the Git objects directory, they will be stored at this exact path. So if this is the hash, the first 2 characters of the hash will be sliced, and then that will be used to create a new directory. And the rest of the 38 characters will be used as the name of the object file itself. So this file contains a header and the contents of the blob object compressed using zlib compression. So every Git object file contains a header and the contents. All type of Git objects contain a header and the contents. Everything inside of that file is compressed first and then stored. So the compression algorithm used by Git is known as zlib. Zlib compression is a widely used data compression library that provides lossless data compression. In the context of Git, zlib compression is used to compress objects, blobs, trees, commits, and tags to save space and reduce the size of the repository. Zlib uses the deflate algorithm, which is a combination of LZ77 and Huffman coding. Next, let's talk about the object header. So each object, blob, tree, commit, and tag is stored with a header that contains the metadata about that object. The header precedes the object's actual data and is crucial for Git to identify and manage the object efficiently. So this is an example of how an object file will look like. First, it will contain the type. So type indicates the type of the object. So type can be any of these. Blob, it can be a blob get object type, it can be of tree type, it can be of commit type, or it can be of tag type. Then you have the size, and this size is the content of the file in bytes. Then you have a null byte separating the header and the actual content. So this part forms the header, and then there's a null byte, and after that the actual content comes. So content is the actual content of the file. When we talk about the blob object type, the blob object is used to store the content of files. So a file can be a text file or a Python file or any single file. Every file in the repository is stored as a blob object. So every file is converted or stored as a blob object by Git. This allows Git to efficiently track file contents and changes even if files are renamed or moved. So for example, this is how a blob object file would look like. So first is the type as we previously discussed. Then this is the size in bytes. This is a null byte. And then we have the actual contents of the file, which is hello world in this case. So then we did stage 2 where we learned how to read a blob object file. So now we understand how a blob object file looks like and how it is stored. We implemented the git cat file command. So in this stage, you are provided an existing blob git object. You're already provided a blob git object. You're supposed to read this git object and you are supposed to implement this command to read this object. In order to read this object, obviously you are provided the SHA of this object file. From this SHA, you can find out the path where this object file is actually stored. So the first two characters form the directory inside of the Git objects directory, and then the last 38 characters is the file name. Since this object file is stored using zlib compression, we need to first uncompress this file in order to read it. After uncompressing it or decompressing it, we got the file. We can read the contents of the file. So the contents of the file contains the header and the contents of the file from which this blob object was created. So you can separate the header and then the actual contents and print just the contents of the text file. In stage 3, we learn how to create a blob object from a simple file. So first we are given a file, we can read the content of that file. Then we can create the contents of the blob object file. So the blob object has a header, the size in bytes. So in our case, the type here is going to be blob. After reading the contents of the file, we can find the size of the file in bytes. And then we add a null byte and then finally add the contents of the file that we just read. So after creating the blob object file, we can compute the SHA of this blob object file. So this content is used to generate the hash. And then using this hash, we can find out the object file paths, first two characters, slash the last 38 characters, and then store this file at this provided path after compression, after zlib compression. So that's all we covered in the last video. In this video, we are going to start from stage number 4. All right, so I am back on Code Crafters. Let's resume the Build Your Own Git challenge. So we are on stage number 4. Let's begin. In this stage, you'll implement the git lstree command, which is used to inspect a tree object. So in the previous few stages, we were working with the blob object. Now we are going to tackle the tree git object. Let's see what tree git objects are. In this stage, we'll deal with our next Git object type, which is trees. Trees are used to store directory structures. A tree object has multiple entries. Each entry includes a SHA hash that points to a blob or tree object. If the entry is a file, this points to a blob object. If the entry is a directory, this points to another tree object. Okay. So a tree object has multiple entries. The first one is a SHA, either representing a blob or another tree, or it is the name of the file or the directory, the mode of the file and directory. These are the different modes. Okay. This is a simplified version of the permissions you'd see in a Unix file system. For files, the valid values are these: regular file, executable, and symbolic link. For directories, the value is this one. Okay, for files, these are the valid values, and for directories, this is the valid value that we are going to be using in the context of this challenge, I suppose. There are other values for submodules, but we won't be dealing with those in this challenge. Cool. For example, if you had a directory structure like this, so we have a directory called your repo, which has three entries. The first one is a file, the second one is another directory, and the third one is also another directory. And each of these directories have a couple of files inside of them. So the entries in the tree object would look like this. Okay. So this tree object has three entries. Okay. Each entry has a SHA, name of the file or directory, and the mode. So first one is the mode, the second is the name, and the third one is the SHA. So line number 1, 044, indicates that directory 1 is a directory with the SHA hash, this. Line 2 indicates that directory 2 is a directory with the SHA hash, tree SHA2, and line number 3 indicates that file 1 is a regular file with the SHA hash blob SHA. Cool. Directory 1 and directory 2 would be tree objects themselves, and their entries would contain the files slash directories inside of them. So these two directories refer to two different SHAs or two other tree objects. So in this example, these two tree objects would have their own entries. For in directory 1, I guess it would have two entries for two blobs, and the third one, and the directory 2 would have another entry for the third blob. So let's see the command that we are going to implement. The get ls tree command is used to inspect a tree object. Okay, for a directory structure like this, the output of get ls tree would look like this. So if you do get ls tree and provide it a SHA of a tree object, it is supposed to print the entries, I guess. Okay. Note that the output is alphabetically sorted. This is how Git stores entries in the tree object internally. In this stage, you'll implement the get ls tree command with the name only flag. Here's how the output looks like with the name only flag. Get ls tree name only, tree SHA, $1, $2, and file1. The tester uses name only since the output format is easier to test against. We recommend implementing the full ls tree output too, since that will require you parse all the data in the tree object, not just file names. Okay, tree object storage. Let's see how tree objects are actually stored. So just like blobs, tree objects are stored in get objects directory. If the hash of a tree object is this, the path would be, okay, got it. The first two characters sliced, and then the rest of the characters as a file name. The format of a tree object file looks like this after decompression. So the first line is supposed to be the header as far as I remember. The type of the object, which is tree in this case, the size in bytes, the null byte, and then the content. Okay. Let's read the description. The above code block is formatted with new lines for readability, but the actual file does not contain any new lines. The file starts with tree, size, and null byte. This is the object header, similar to what we saw with blob objects. Cool. After the header, there are multiple entries. Each entry is of the form mode, name, null byte, and SHA. Cool. In the case of the blob, it was the contents of the file itself. So mode is the mode of the file slash directory. Check the previous section for valid values. Name is the name of the file or directory. This is something that we are going to need to implement our command. We are supposed to extract this information and print that when we are implementing this challenge. This is the null byte, and then there is the SHA. And the SHA in this case, 20 byte, SHA1 hash. This is not in the hexadecimal format. You can read more about the internal format of a tree object here. The tester will use a program to initialize a new repository. It will create a directory, enter into that directory, initialize it with the help of our own Git. It will create a Git object. It will then run your program like this with the ls3 command that we have implemented. And it will verify the output of your program matches the contents of the tree object. For a directory structure like this is the expected output, sorted alphabetically. Okay, notes. In a tree object file, the SHA hashes are not in hexadecimal format. They are just raw bytes, 20 bytes long. In a tree object file, entries are sorted by their name. And the output is also supposed to be in alphabetic order. The output of ls tree matches this order. Cool. Let's get back to our VS Code. I changed the theme of my editor here because when I'm recording this space, the software that I'm using for recording, it actually decreases the saturation a little bit, which is why the contrast between the text and I guess the background of the editor was not ideal for viewing purposes. But I actually like that theme when I'm personally working. I do not like too much of a high contrast. I don't know if that is better or worse for your eyes. That's just my preference. Right, so let's add another case statement for the ls3 command. ls3, that was the command, right? ls3, and then this is the flag. Copying the flag, creating a new block. Mm, no, we want the flag here. This is actually going to be the flag, and this is going to be the Prisha process dot arg. The Now we have to check if the flag is what we're expecting. Pretty print object, Prisha. Let me get back to that. Pretty print object Trisha. So this is the function that I created previously to pretty print the blob object. Let's see if I can reuse this function to pretty print the tree object as well. Let's discuss the approach a little bit. Okay, I am given the tree SHA, right? From that SHA, I need to get the object file. I have to get the object path and then get the object file. Then I have to deflate the object file and then do the rest of the processing, which is required for printing the directory structure or for printing the contents of the file. So up till step number 3, these three steps are similar to what we were already doing in the blob object logic. So hopefully I can reuse till this point and then take out this logic and then use the header depending on the header. If it is blob, do blob stuff, or if it is tree, do the tree stuff. Okay, pretty print object. Let's just call it object SHA instead. Object SHA. Okay, I don't want to blob SHA. Okay, let's not do that. Let's just manually change it for now. Object path. We've already written this logic. Object content. Compressed data from object content, and then unzipping or uncompressing that data. Okay, compressed data. If error, logging the error. Else, uncompressed data is this, const content is this. Okay, let's do one thing. Okay, let's split on this space and use the first element in that list or the first value in that list to check what type of object it is. Let's split at a space and then use the zeroth element. This is going to be object type. Maybe I should not have changed this line of code. Object type if, okay, I'm going to use another switch statement because we have one more type of object. Case blob, case tree, case commit. Let me remove commit and tag for now. We are going to be implementing commit later on as part of this challenge. So I'll add it later on. Or maybe let's just keep it here. I'll remove the tag one. I am not sure if we are going to be covering tag in this. Yeah, I don't think we are covering tag in this challenge. Default unknown object. I got it. Blob. I don't want to do console.log. I want to do pretty print blob. Pretty print blob with the uncompressed data. Sorry. And then here instead, I want to do pretty print tree with the uncompressed data. Let me create this function as well. Function pretty print blob. And I want this. And I want this. Now let's create the pretty print tree. Uncompressed data. Uncompressed data. So again, we want the content after the null byte. This will be the content. Then what if I split it again with this space character? So the above code block is formatted with new lines for you, but the actual file does not contain new lines. So it will be mode. Then it will be name till mode. And then again, this. Or what if I first split it at null bytes? Then for every alternate element in that list, I again split it with the space. Okay, let's do that. Const, what should I call it? Entries, probably. I'm just going to call it entries for now. Content dot split at null bytes. And then for, yes, for const entry of entries, split it at yes. So for the first element, it is only going to have a mode and name. For the second one, it's going to have SHA, mode, and then name. So we only care about the second split item. I guess path and then console.log path. Hopefully this should work. Let's see. It's my terminal. cd work slash code crafters get JavaScript, and then is it code crafters test. Initiating test run. I also changed the logic for the first or the second challenge. So I'm not sure if it's going to run all of the tests or just the test for the current stage. Okay, running tests for stage KP1 reader tree object. So I guess it just ran the tests for the current stage. Initialize a Git repository. Your Git. So this is the command that the tester ran. Then we have const object content, blob path. I guess I forgot to change the name of a variable when I make the changes. Blob path, yes, this is supposed to be checked path. Let's run the tests again. Okay, unknown command, did I do something wrong? Let me print the values of flag and tree sha to check if I've extracted them correctly or if I've set them correctly. Okay, name only. This is the flag and this is the sha. My command is correct. Why is it printing unknown command? Why is it entering into the default block? ls3, name only, throw new error, 49 or 47. Yes, unknown command. I'm pretty sure I'm overlooking something which is very simple. And let me, I have a break here. Oh, got it. Wow. I just forgot to add a break statement inside of my block. Okay. Mercy, Humpty, Monkey as output. And I'm only printing the first one. All right. Let's go back to my function here. Where is pretty print? Preprint tree. I want to see how my entries also look like. So this is my entry. Only the first line. Okay, I get it. What's the issue here? So content is not going to be this. It's going to split at every null byte. So the first one is going to be the header. The second one is going to be this part. The third one is going to be this part, and so on. So this is just going to be entries like this. And let's just print the entries and see how the array looks like. Defined, undefined, undefined. Oh, okay. So the undefined is coming from here, I suppose. It is monkey. Where is my entries array? Ah, sorry. I do not need the first element. Entry is going to be the entire array. So here's my array. As you can see, the first one is the header. So we can discard the first element. Yeah, so the method to remove this would be shift. And then we have the rest of the entries. So the first entry, we can split at the space and then use the second element. Similarly, for the second one, we can split at the space character and so on. The last element as well we are not going to be needing, that is just going to be the SHA. If I am correct, yes, the last element is going to be after the last null byte, which is just going to be the SHA. So I need to do entries dot shift, removing removing the header from just removing the header, I suppose. And last element, in- last element entry dot pop. This is going to be removing the this is going to be removing the last SHA. So for constant trace of the entries, entry dot split, we need the element at the first index and then console.log path. Hopefully this should now work. Hmm. Okay, we got till vanilla, do or see vanilla, but we have these extra bits of undefined. Why is that? Let's print entries once again to see what's going wrong after we remove the first and the last element. Humpty, horsey, Humpty. Then Dumpty, Horsey, and Humpty. So this is our output, Dumpty, Horsey, and Scooby. Expected Dumpty, new line, Horsey, new line, Scooby, and then a new line. As output, got ah. So we were printing the arguments as well. Back in the switch statement, removing this log. Now this should pass. Test passed. Congrats. Submit your changes to move to the next step. So it ran tests for all of the stages, running tests for stage IC4, reading a blob object, reading a blob object, reading a blob object, and initializing the Git directory. So this test also passed. I just refactored the pretty print object function as well. So this means that this function is also working. Next, I'm just going to submit my code to move to the next stage. Oh, so now my test failed because of this. Scooby Dooby and then this. I did not change any code, but now it's failing. So my output is changing every single time. Sometimes it's passing, sometimes it's not. Okay, so my output looks different every single time I run my code. So I'm probably doing something wrong here. Maybe this is the issue here. Let me print the entries and run my code a couple of times to see what is happening. So in this case, the first one got it. Okay. I guess these shas themselves sometimes have a space in between. Maybe that's why when I split them, the splits are not working correctly, I guess. Let me rerun this cook test and see. So for example, here I have donkey, I have monkey, and then I have this. So this SHA got split itself because probably the SHA had a space in between. The one thing that I can do is only print this if path exists. I suppose this is going to work, but I am not sure if this is the best solution. So the test passed this time. I think this solution works, at least for the provided test cases. I was able to successfully submit my code as well. This works, but I'm going to look at the code examples and see what other people are doing. I Yes, mark the stage is complete. Code examples. This is mine. SHA directory, file name, file path, inflated content, content. Again, splitting at this. Inflated content dot slice one does inflated content to string, split at the null byte. This becomes dot filter value. Value includes a space. So this solution just checks if that value includes a space or not before splitting it. What I'm doing is splitting it and then seeing if there was a second part to that split value or not. And if it exists, only then printing the path. Let me check one more example here. Size, name string. Okay, so this person is making use of regular expressions. Again, checking if a space exists or not. All right, so I guess my solution is good enough as any. Let's move on to the next stage. Stage number 5. In this stage, you'll implement writing a tree to the Git objects directory. In the last stage, we read a tree object. In this stage, we are writing a tree object. So we are supposed to implement this command, git write tree. The git write tree command creates a tree object from the current state of the staging area. The staging area was the index file. The staging area is a place where changes go when you run git add. In this challenge, we won't implement a staging area. We'll just assume that all files in the working directory are staged. Here's an example of using git write tree. So creating a file, git add test.txt, git write tree. This is going to create a tree object. And then print the SHA of that tree object to the output. The output of tree object is the 40 character SHA of the tree object that was written. Okay, so to implement this, you'll need to iterate over the files and directories in the current working directory. If the entry is a file, create a blob object and record its SHA hash. So we've already created this function to create a blob object. If the entry is a directory, recursively create a tree object and record its SHA hash. Once you have all the entries and their SHA hashes, write the tree object to the git objects directory. If you're testing this against git locally, make sure to run git add before git write tree so that all files in the working directory are staged. Tree file storage recap. We covered the format of a tree object file in the previous stage. Here's a quick recap of what the tree object file looks like after compression, before compression, sorry. So the header and then the different entries. The above code block is formatted with new lines, but actually it does not contain new lines in the actual file. Starts with the header. After the header, you have all of this stuff. Then you have tests. The tester will initialize a Git repository, create some random files and some random directories, and then run our program like this to create a tree of the current working structure. You're expected to write the entire working directory as a tree output and print the 40-character SHA. The tester will verify the output of your program matches the SHA hash of the tree object that the official Git implementation will write. Notes: remember to ignore the .git directory when creating the entries in the tree object. The implementation of Git write tree will need to handle nested directories. Recursive implementation will help here since you'll need to create tree objects for each subdirectory to be able to create the parent directory's tree object. The implementation here differs slightly from the official implementation. The official implementation uses the staging area to determine what to write. We'll just assume that all the files in the working directory are staged. So we're not going to create the staging area here and just assuming that whatever is in the current working directory except the Git directory is going to be a part of the staging area and then creating a tree object out of it. And let's go back to VS Code. Let's think about the approach a little bit. Approach. So I have to first read the directory for every file in the directory, for every content in the directory. If it is a file, create a blob object and return the SHA. We have this part implemented. If it is a directory, run this, create a tree object and return the SHA. And then this is going to be a recursive function. So what to do with these SHAs? Once you have the SHAs for every content in the directory, then you're supposed to create the tree object file. First, I want to create a tree get object content file. Whatever. Create tree get object content, which will have header, size plus null, sorry, header size, null byte, and then the content. This part of the approach is going to figure out the content. So I guess this will come later on only. For every content in the directory, we have to create an entry for that. Entry looks like this. Mode, name of the content or name of the file or directory, null byte, and then the 20-byte SHA. So this is the SHA that we have generated. And in this case, we do not want the hexadecimal format. We want the byte SHA itself. Mode, let me see what is going to be the mode. So for our directory, the mode is going to be this. Let me write it down. Directories, the value is this. And for files, the valid values are this. So we are only working with regular files, I guess. So I guess this is going to be the mode. 10064, correct. And then we just create the get object content. And then we compress this file or compress this content using zlib. and then create the file, add the object path. Object path we have to figure out from the hash. I guess I have to first find the SHA, then compress the content, create the file at the object path calculated from the SHA. I guess that's it. That is supposed to be my approach. All right, then let's start implementing the command. The command is going to be write tree. Yes, it was write tree. And before I forget to add the break statement, let me just add it first. I do not have a flag. I do not have a SHA as well. Just have to do create tree object. And that's it, right? Right tree. Yep. Then let's create our function. Function create tree object. Okay, so previously I created this function write object. Mm, object. Okay, I'm going to call it write log object. Instead, write log object, and this I'm going to call write tree object, just for naming consistency. Write tree object. So I'm wondering if I could reuse some of the code from write blob object. Let's refactor this code later on once I figure out this. Let's do the refactoring later on. The write tree object, first one was to read the current directory structure. All right. It's as if my AI assistant is listening to what I'm saying. Const dot path equals to process dot current working directory. So this is all right. So some code was suggested. Looks incomplete. So readdir is the method that is used to read a directory, providing it the dir path, current working directory, error files. So if error reading current working directory, else here. All right. Const tree content files. Okay, interesting. So const tree content files dot map. Files is going to be an array. Let's just see what files look like. Files is this dot git, which is a directory, donkey, dumpty, horsey. So we need to ignore the dot git directory. Const file path, dot path. If file is not equal to dot git, only then do this stuff. Const file path equals to path dot join dot path and the file path. Const file starts. Okay, so now I need to know if the current file is a directory or a file. I suppose file starts is going to give me that information. Let's print the starts for each file, see what all information it has. Okay, so starts object, you have size, blocks, mode, 16877. Is this the same mode as our file modes? I don't think so. Size or dev. Okay, I'm not quite sure. So I'm not quite sure what property here actually is useful for me. Let's just ask ChatGPT here. I have a file path. I want to know if it is a file or directory. And to check if a given path is a file or directory, if it's module, the stats is file. Okay, so there is supposedly the its file method that is going to let us know if it is a file or a directory. Cool. I'll start sync. So if file starts dot is file, create a blob object, write blob object, otherwise, not otherwise. Else file starts is directory, else I guess do nothing. Oh, I guess write tree object and here file path. Why is it underlined in red? And here write blob object. And here I'm supposed to again give it the file path. There's the complete path. So right now the issue is our write tree object does not accept any arguments. If I do this path, not just this dir path, and move it inside of the switch statement, and then pass it the dir path. Right object also takes a file path. But right object, file path. I need to return the hash, I guess, from this function. But our hash is being created. Create hash, blob content, create hash. I do not need the hexadecimal, I just need the hash. So return hash, create hash, return hash. Hash hex is going to be this. And we are going to use the hexadecimal version while creating the or writing the blob object. Here, here, and write file, and then return the hash. Write tree object. This is going to return a hash. And this is also going to return a hash. Okay. Do I have some syntax error in my code? Expected mode. I'm just going to ignore it for now and see what's the error when I run the code. And then I'm supposed to use this hash. Just a second. Find the SHA. Okay, for directory, the value is this, and then create an entry. So I'm supposed to write an entry here. So const entry is going to be the mode. When I printed the mode was a bit different than the values suggested in the challenge. So for directory, again, const entry is going to be the string file, the name of the file, correct? Not the entire file path, just the name of the file, the null byte, and the SHA. Cool, cool, cool. And for directories, this is the mode. And for files, this is the. Then these entries are going to be appended to the content. Let's do this. New directory, files. Let me remove this. Tree content, tree object content. And then let's just say just the content is going to be this empty string. And we are going to, let me just do this. Let entry, and then entry equals to this, entry equals to this, content is equals entry. After doing this, after creating the entry, create a tree object content. So I have this, I need this. Const tree object header is going to be content.length files. No, this is going to be tree. This is going to be the size of the content in bytes, though, I guess. No, let's just do this for now. And then the null byte, and then the content. Let's check the right blob object part first. So I need to reuse this part, right? What I extract it out in a function? Function write object file, and then give it the file data. File data, create hash out of file data, hash hex. Am I supposed to print it out? File data, compressing data, object dir path, object dir path, object dir path, write file, buffer, and return the hash. Am I supposed to return the hash? Type of object. So here all I need to do is this. Okay, remove this. this return write object file. File data in this case is going to be second. Okay, file data only. File data is this write object file data. No, return object file and this block content, write object file, block content, object data. Okay, const hash, create hash. Free object header, and then we are also supposed to return tree object content. See, tree object content. This should be called. Okay, let me rename this. Okay, I don't need to map this. I guess this could just be for each. This should be out of the for each loop. So, so I have some syntax error here which I'm not able to find. I am unable to see what's the syntax error here. So I'm just going to ask ChatGPT to spot it for me. Check for syntax errors. Has a syntax error in the else clause. Which one? So encourage else if statement. Here is the corrected version. What else if? Where is the else if? Else, else. Ah, okay. Now let's run the code. So I am printing all of the shars, and I just need to print the sha of the tree that I've created. That is happening. First of all, I do not want to print it here. Let me do this. Let's do this. Hash and hash hex. Let's return both of these values equals to this. And write blob object. That's when you do this on it. So let me return hash. And what was the order? Hash has hex. Hash and hash in the hex format. Now here as well, to do this, hash, hash hex. Write object file will return this hash and hash hash and hash. We need hash hex. And we just need to print the hexadecimal hash. So again, here, if I do, it is going to print it for every directory because of the recursive nature. So here again, if I do this, it's going to print it for every directory because of the recursive nature. I only want to do it for the top level directory. So directory object. So if I do this, turn from here and just print it inside here. Const hash hash hex. Okay. This should probably work. Directory object is not a function or its return value is not retrievable. Okay, directory object is read file. Hello everyone. So today is a fresh day of doing this challenge. I just went through the code that I wrote the last time, and I also tried to run the tests and see what was the error I was getting the last time I stopped recording. I also had to update my Codecrafters CLI. So before we continue with this challenge, let me just quickly give you a recap or a walkthrough of the code that I wrote the last time. So we were implementing this new command, write tree, that creates a new tree object. To do that, we were not making use of the staging area. We were making use of all of the files in the current working directory. So that is why we did, first of all, did this, got the current working directory, and passed this current working directory to the write tree object function that we created. So this function returns a hash in the hexadecimal format, which we just print. So this is supposed to be the output of the write tree command. As far as I remember, let me double check. Yes, so get write tree is supposed to create a new tree object and print its hash. Now let's check this write tree object. This function takes a directory path and it reads all of the contents of this directory. So it goes through all of these files one by one. The first thing that we are doing here is ignoring the .git folder because we don't want to add it inside of our tree object. Next, we get the complete path of the current file. And then we check using the start sync method if the current file is a file or if it is a directory. If it is a file, we are creating a blob object for that. If it is a directory, then we are again running the same function recursively to create a tree object for this nested directory. So both of these functions, write blob object and write tree object, return the hashes that we are then using to create the entry for that particular content inside of the directory. And then that entry is appended to the content of the object. Then we finally construct the tree object content, how it's going to look like. It's going to have the header, and then it's going to have the content that we just created after looping through the files or the contents of the directory. And then at last, we use this tree object content to finally write the object file. So last time we refactored some code, took out the logic from the write blob object file and separated it and created a new function because we are going to use this logic of writing the object file by providing it the file data and then compressing it and storing it at the appropriate Git objects path. So when I run the tests here, This is the error that I'm getting. Type error, write tree object is not a function or its return value is not iterable. So this is the line of code that is erroring, line number 49. So here we go. So we know that write tree object is a function because we have created this function. So I suppose the error that we are facing is that the return value is not matching with this destructured syntax. So it's probably not returning an array as I am expecting it to. So let's do one thing. Let's comment out this piece of code. And then I'm just going to print out the return value of this write tree object function. This also I need to comment out. Let's run the tests again. So initialized git directory, and then this console statement that we just added prints undefined. So this write tree object function is returning undefined, which is why it is erroring at every place we have called it like this. So our write tree object function actually returns this from inside of the else block. So if everything is going fine, if we are able to read the directory successfully, our code should enter this as else block and then return the result of this function here. So write object file, tree object content. All right, so after adding a bunch of console statements, it looks like this callback function is not reached or this console statement is never printed. Or rather, I should say that this write tree object function returns before we actually trigger this callback function. This is because this fs.readdir is an asynchronous operation, and we are not waiting for this asynchronous operation to complete. It just moves on to the next line of code and this function returns, which is why it is not returning the hashes or the hash values as expected. So instead, what we need to do, removing the console statements first. Instead, I'm going to use the sync version of this function, fs_readdir sync, like this. So const files equals to inside of a try and catch block. Sorry, catch. Moving this inside of the try block. Let's run this code now. Now, error reading directory, error is not defined. Forgot to add the error here. Okay, error reading directory, type error, write blob object is not a function or its return value is not iterable. Let's see. Write blob object, read file sync. This function also needs to be a sync function, I guess. Stat. Yep. catch. File stats. Let's run the code again. Error reading directory. Type error, write blob object is not a function or its value is not retrievable. I have used a mix of synchronous and asynchronous code. Let's see what's happening again. This again, I suppose, is an asynchronous function. Try and catch. Right. At least the errors disappeared. Now I have some output. Get object file does not match official Git implementation. So we were able to successfully write the Git object file, but it does not match the expected output. So diff after decompression, expected bytes 0 to 100, hexadecimal, ASCII, and actual is this. So this is what is different. This content dot length. So this is supposed to be the size of the content in bytes instead of the length of the string. How to find the size of a string in bytes. Size in bytes, buffer dot byte length. Let's try it out. Content and size in bytes. Hmm. So this is expected and this is what I wrote. Object. All right. Print the entry in each case. Console.log entry. So these are our entries, the mode, the name of the file, and the SHA. So I'm not printing or I'm not adding the SHA correctly. Let's see. Hash console.log hash console.log hash. All right. Write object file and create hash. The create hash function returns hash, which is an object. Let's see what is the return value of create hash. Create hash returns a crypto.hash object that can be used to generate hash digests using the given algorithm. And what about the hash digest function? Calculates the digest of all the data passed to be hashed. Using the hash.update method, if encoding is provided, a string will be returned, otherwise a buffer is returned. So we need a buffer, I guess. Hash object and const hash equals to hash digest. Hash object digest, hash object digest. Let's print these two values. Hash. Let's try and print the value of hash. Okay, some error occurred. Digest already called. Okay, the hash object cannot be used again after hash digest. Method has been called. Multiple calls will cause an error to be thrown. How to get the digest in hex and bytes format. So recreate the hash object to get the digest in bytes format. Or let's just do this, convert bytes to hexadecimal. Bytes to string hex. Console log hash hex. Let's print the entries once again. Console.log entry. So my object file differs from the actual object file, and the first difference happens in the size itself. So the size of my file and the size of the actual file is different. My best guess is that I'm probably doing something wrong with the hash. Is it, can I, so this hash is supposedly a buffer, and I am concatenating a buffer inside of a string template. I think the error might be here itself. Let me ask ChatGPT. Is this correct? Buffer, where buffer is a buffer array. When you log a buffer object directly using template literals, it will not display the contents in human readable format. Instead, you should have convert the buffer to a string representation first, such as a hexadecimal string. Here's how you can do it correctly. What will be the output? When you log a buffer object directly using a template literal in Node.js, buffer, the output will be default string representation of the buffer object. For the given example, it will look something like this. The output shows the buffer contents in hexadecimal format with thin angle black brackets, which is the default way. What if I want to add a string to a buffer? Let's try this out. Buffer.from and buffer.concat. create buffer. Okay, let's do this. New buffer. You can I do this? Okay, buffer from buffer from buffer.concat hash. Similarly for this, for this as well, buffer.concat content and entry, and here as well. Tree and content and this. This should be content.byte length. Let's test it out. Oh, so that worked. I did not expect it to work. Let's submit the code then. Code crafters, submit. Yep. Looks like this is exactly what I was missing. So I'm going to stop here now because it's already going to be a really long video for me to edit. I'm going to finish this challenge, the last two stages that are remaining in part 3. So let me know if you want to see part 3 in the comments below. And if you want to try out the challenge yourself, I've left a link to the Code Crafters challenge in the description box below. I'll see you guys in the next one.